All right, let's take a look at exercise 29 in chapter 21, stress and weight in rats. In a study of the effects of stress on behavior in rats, 71 rats were randomly assigned to either a stressful environment or a control, non-stressful environment. After 21 days, the change in weight in grams was determined for each rat. The table below summarizes data on weight gain. The study report gave the standard error of the mean, S divided by root n, abbreviated as SEM, rather than the standard deviation. What are the standard deviations for the two groups? Well, if we know, grab a pen, if we know that the standard error for the mean is S divided by root n, then we could solve for S by multiplying each side by root n. So S1, we'll call group 1 the stress group, and to group 2 the no stress group. Then the standard deviation for group 1 is the SEM for group 1 multiplied by the square root of 20, which is 13.416. And S2 will be 2 times root 51. Looking again at the standard error for no stress and multiplying by root 51, giving us 14.283. By using the option 2, okay, so what degree of freedom does the conservative option 2 use for t-sample t procedures for this data? We choose the lesser between n1 minus 1, which is 20 minus 1, or 19, and n2 minus 1, which is 51 minus 1, or 50. We choose the least one, and we call that our degrees of freedom. Test the null hypothesis if no difference between the two groups, the two group means against the two-sided alternative, so not equal to. Use the degrees of freedom from part B. Okay, so we have a null hypothesis that there's no difference between the real means of the population of stressed out rats and not stressed out rats. And our alternative hypothesis is two-sided, therefore not equal to, just there's a difference. The alternative hypothesis is there's a difference, right? They're not equal. Let's see, we need our t score. So let's look at finding the standard error for the difference in means, which is S1 squared divided by N1 plus S2 squared divided by N2 square rooted, right? And then that is approximately 3.605. 6305. So our t-score, which is the difference in the means divided by the standard error for the means, that is 26 minus 32 divided by 3.605. That's a subtraction there. I get negative 1.664. All right, now remember, we now need to use our degrees of freedom from part B. So with degrees of freedom 19 from part B, using table C in our book, we can see that our p-value is between 0.10 and 0.20. And in conclusion, because the test requires a conclusion, there's little evidence in support of a conclusion that mean weights of rats in stressful environments differ from those of rats without stress. We have a p-value between 0.10 and 0.20, representing our 90% confidence interval and an 80% confidence interval. So we're not, it's not very rare, is what we're saying. There's little evidence. So in conclusion, there is little evidence in support of a conclusion that the mean weight of rats in stressful environments differ from those of rats without stress. There's little evidence to conclude that the mean weight of rats in stressful environments differ from those rats without stress, which I find surprising because I thought the less stressed out rats would be a little fatter. But apparently there's not very much evidence for that.